Okay, good afternoon and welcome to MAE 113, Calculus for the Liberal Arts. This is Richard Carr speaking, and well, you just finished our last quiz of the semester, so hopefully it was straightforward. Those marks will get released later once everyone has finished writing it. We're going to go through the quiz or the test solutions from test 2, which got emailed out. I'll try my best to answer questions as opposed to like marking or like what marks, or I didn't even get a chance to input the marks yet into the book, so I don't know what the statistics are yet, but they looked fine. So I'll just kind of work through these. I think I have about 35 minutes left because of the quiz. But let's get through this. Okay, so question 1. For 3 marks, it says that I have a function here. I have it defined as a piecewise, meaning that part of the, for x less than 0 or x less than 1, it's x cubed plus x squared. It's unknown between 1 and 12, and I have the square root x minus 3 if it's x greater than 12. So the first thing that I'm going to do is, how could I make this f continuous, is by actually coming up with just some line that connects it. So what I'll do is I'll find what that value is here at 1 and what the value should be at 12, and then I'll just connect it with a straight line. So at 1, it would be nice if I could have 1 cubed plus 1 squared. That's 1 plus 1 equals 2. So the point I want to connect is 1, 2. And over here, I'll substitute 12 in here into this part. So I have 12 minus 3, which is the square root of 9 over 3. So therefore, the second point I need to connect is 12, 3. So the slope for that is the difference between the y's, so 3 minus 2 over 12 minus 1, so that's 1 over 11. And to get my y-intercept, using my y equals mx plus b, I'm going to use, let's use 1 and 2, since that's an easy point. So I'll use 2 equals, so I'm going to substitute my 2 goes into the y. My slope is 1 over 11 times 1 plus b. And then I'm left with 1 over 11 plus b, 2, or 2 minus 1 over 11 equals b. So I could rewrite this so that I have it as over 11, so it's 22 over 11, so that would give me 2. Minus 1 over 11 equals b. b equals 21 over 11, so therefore y equals 1/11 x plus 21 over 11. So that's question 1. That's all that we needed to do. So that's how we would connect it for that interval from x 1 to 12 to make this function up here, f at x, continuous. Okay. Question 2. It says evaluate the limits, and yes, they do exist. So that means I need to do some algebraic manipulation first. And the way to do this one is I will factor it. So on the top, the way that I would factor that is x plus 1 and x minus 3 over x minus 1, x minus 3. These cancels, so that I'm left with just the x plus 1 and the over the x minus 1. I can now substitute in the values because I the denominator is not 0. So I have 3 plus 1 over 3 minus 1, which is 4 over 2, and that equals 2. Okay, that was 3 marks. The next one is, did I do it and make sure I am doing my arithmetic correctly? This next one is, I have a radical here, and to handle that, I need to use the radical conjugate. So to do that, it's this, the top and the bottom. But instead of the minus, it's going to be a plus. And that means, if I expand this now, what I'm left with, I have the square root times the square root, so I just get the inside of that, so that's 9 plus delta p. I'll get the 3 times the square root of 9 plus delta p, and I get the minus 3 and the square root 9 plus delta p, and then a minus 3 and a plus 3, so that's a minus 3 times a plus 3, so that's minus 9, all over. I have the delta p over the square root of 9 plus delta p plus 3. So this cancels. I also have the 9's cancel, and I still have these delta p over in the numerator, so I got the delta p. So those cancels as well. And so I'll take my limit here. I have 1 over the square root of 9 plus 0 plus 3, or square root of 9 is 3, and 3 plus 3 is 6. So in terms of that, I saw that some people had sometimes multiplied, so it was like 3 times 3 gave you 9, and no, there was a plus here. Probably in this section, just keeping an eye out for just the arithmetic. Okay, in this one, to handle the limit with the infinity, I divide everything by the largest term, the largest degree term. And what I'm left with is this. I got 1 over 1 minus 9 over x squared. And if I take the limit of that, this one right here, that is 0. So that leaves me with 1 over 1, which is equal to 1. Okay, so now we get into, we switch from doing kind of the pure skill-based question to an application. So the first thing that we have is an app is available for purchase for smartphones. The designer estimates that the app price P in dollars is related to the number of sales, F of P, per week by the demand function, which is here. So they're kind of saying that if I sell X many, this is how many that I expect to sell at this particular price. Currently, the app price is $3. So we're asked to find the derivative of that. So what I would do is rewrite this so that I have that radical as an exponent to the 1/2. And if I take the derivative of that, I don't touch this term out in front, the 1/3, but the 1/2 comes down, and then I leave the inside alone because I'm doing chain rule. And over here, I have the 1/2, and it comes, I do 1/2 minus 1, so that becomes a -1/2. And I still need to take the derivative of the inside here, so that becomes minus 2p. I can cancel out this 2 and this 2 here, so that I'm just left with minus p over 3 square root 25 minus p squared. So that's it for 3 marks. Then the next one is plug in 3 into this. So the idea is I wanted to find out, like, basically what we're doing is we're doing a test value. So I substitute that in, I get minus 3 over 3 times the square root of 25 minus 3 squared. So minus 3 over 3, 25 minus 9. Oh yes, and also the 3's can cancel. So I'm left with minus 1 over the square root of 16. The square root of 16 is 4, so it's -1/4. That's less than 0. So from this, I can conclude, because again, between all these values here, if I substitute in from 0 all the way to 5, they're always going to, the derivative here is always going to be negative, because here it's going to be positive, and then I get that negative, so that makes it negative. So yes, the demand function is decreasing. And that's good. That's usually what we expect with a demand function. Then the next one is to find the elasticity of the demand function. So the elasticity just requires us to remember what that formula was. So we said that the elasticity of the price P is equal to minus P of the derivative of the demand function over the demand function. So what that means for us is we get minus P, and then I put in my derivative, which I've already calculated up above here. So I'll put that here. P, so I have a minus P, and then right here I'll put minus P over 3 square root 25 minus P squared. And then I will also get the 1 over f of p, so 1, and in the bottom here I'll put what I have up top here. So that's the 1/3 square root of 25 minus p squared. What's nice is that I can see that I have a 3 and a 3 down here, so I can cancel that out. I have a minus and a minus, so that becomes positive. I am left with the p squared up top, and then in the denominator I have square root times a square root, so I just get the inside. So it's p squared over 25 minus p squared. That's it. And then the next one, substituting in our value of 3, I get 3 squared over 25 minus 3 squared. So that's 9 over 25 minus 9, or 9 over 16ths. This is less than 1, so that implies that the price is inelastic at $3. Okay. We have a local publisher is planning to sell a limited edition book about historic buildings of RMC, and the book production costs in dollars. So here's the cost here, and we have the revenue function. They ask us to find the profit function. So the profit function is the revenue minus the cost. All right, because this is the total amount of money that comes in, and then we need to pay, or let's take away from our costs, and that will give us what our profit is. And so you just kind of, you know, we're doing our substitutions here, what we're told for our formulas. This was something that I saw that people weren't very careful of, this negative sign. So I saw some people not apply this negative sign to here or one of these terms here. So I got minus 4x minus the 5 halves x squared. So I'm left with the still 1/3 x. I'll take the minus 5 halves here, x squared. And 10 minus 4 is 6 plus 6x. You know, find the marginal function basically means take the derivative of the profit function. So, taking the derivative of the above, the 3 comes down in front, so I get 3/3x cubed. I have 5 halves, so the 2 comes down in front, so 2 times x, and I still have the 6x, so the derivative of 6x is just 6. And what I'm left here is 3/3 is just 1, so it's 3 squared, excuse me. And then I'm left with the 5x plus 6. Okay. So we have our profit function, we have our marginal profit function. Then part C says find the number of books that maximizes the publisher's profits on the interval from 0 to 4. So we've already found what we need to do is find the critical points. And the critical points are where the derivative, or our marginal profit function, is equal to 0. So doing that, I get x squared minus 5x plus 6 is equal to 0. And factoring that, I get x minus 3 and x minus 2. And if you want to check that, make sure you can always just expand that out and you get back to the original function. So with that, I have my critical values are x is equal to 3 and x is equal to 2. Then we have to calculate. So we have these values, but I also need to check my endpoints. So another tip, or another thing that I saw that was common, was people substituting into the marginal function, and what we need to actually do is plug it back into the original profit function. So here's my p of x, and I need to check for 0, which is my endpoints, 0, 2, 3, and 4. So what's kind of nice, okay, so I'll rewrite this right in here. So my profit function is 1/3 x cubed minus 5 halves x squared plus 6x. So subbing in my 0, that one should be 0, but I'll write this out. So that's equal to 0. I have 1/3 times 2 cubed plus, minus 5 halves 2 squared plus 6 times 2. So what I get is 8/3. And then I have the I have 20/2. So that goes to 10. And I also get plus 12. So I get 8 over 3 plus 2. And then I just keep kind of going on. I get 8/3 plus 6/3 equals 14 over 3, or 28 over 6. To do the third one, here we go. Just substituting in my values. Oops. There we go. So I get 27 over 3 minus 45 over 2 plus 18. So that goes to 9. So that I'm left with 27. So 9 plus 18, that gives me 27. Minus the 45 over 2. I get 54 over 2 minus 45 over 2, or 9/2, or that's equivalent to 27 over 6. And lastly, I have 1/3 times 4 cubed minus 5/2, 4 squared, plus 6/4. So I get, so that was kind of why there's a hint up here, 4 cubed, that's 64. So 64 over 3 minus the 80 over 2, so that goes to 40. And lastly, I have the plus 24. So that's 64 over 3 minus 16, and that equals 64 over 3 minus 48 over 3, 16/3, or that's 32 over 6. So 28, 27, and 32, this one is the largest. So therefore, the number of books, of course, I was going after profit, but the number of books that maximizes profit is x equals 4. Okay. We're almost done. So we're just on the last question. So for this one, the domain means where this function is defined. And in this case, the x minus 2 cannot equal 0. So that means that x cannot equal 2. So therefore, my domain should be from minus infinity to 2, union 2 to infinity. To find the y-intercept, that's when the x equals 0. So that's f at 0 is equal to 0 plus 2 over 0 minus 2, which gives you minus 1. So that means that my intercept should be 0 minus 1. And my x-intercept is where the y is equal to 0. So 0 equals x plus 2 over x minus 2. Solving for that, I can bring the x minus 2 over to the left-hand side, but that's multiplied by 0, so I'm left with 0 equals x plus 2, or x equals minus 2. So that means my x-intercept should be minus 2, 0. To find the horizontal asymptotes, I have to look at what the behavior is like at infinity, and to do that I need to take the limit. So again, very similar to what we did in the earlier skill question. What I'm going to do is divide by the largest x, so in this case it's x, just x. So it's x plus 2 over x over x minus 2 over x. And so I'm left with one plus 2 over x over 1 minus 2 over x. And just kind of finishing that off, I'm left with 1 plus 2, 1 over x. And then I'm left with 1 minus 2, 1 over x. So we know that those go to 0. And I'm left with 1 over 1, or that's equal to 1. So that means that my asymptote, and again, similarly, for the limit as it's going to minus infinity, it also equals 1. So therefore, the horizontal asymptote is y equals 1. What are the next vertical asymptotes? We already know that the function can't exist here at x equals 2, so x equals 2, since it is a discontinuity and not any kind of discontinuity, it's an infinite discontinuity. Okay. What are the intervals of the function f at x where it is increasing, and what are the intervals where they're decreasing? So again, we need to take the derivative. So in this one, I can use my quotient rule. So the derivative of the top, so the derivative of x plus 2, that's just 1, times the bottom, minus the top, times the derivative of the bottom, so that's just 1, all over the bottom squared. Okay. I can simplify that a bit so that I get x minus 2 minus x minus 2 all over x minus 2 squared. These cancel, so I'm left with minus 4 over x minus 2 squared. To find the critical points, again, critical points is where this function is equal to 0 or where it doesn't exist. And x equals, this is not defined when x is equal to 2 because this makes our denominator equal to 0. So, so that's the what I just need to do is here's my 2. I can do a quick test of my values, like a test value of the derivative here, just to see what the sign is. So I have a minus 4 over 0 minus 2 squared, which means that I have minus 4 over 4, and that is minus 1, which is less than 0. So that means that this is decreasing. And over on this side, I'll pick, say, 3, and that's minus 4 over 3 minus 2, that's squared. And minus 4 over 1 squared, or minus 4 is less than 0, so that means that this is also decreasing. So it's decreasing on negative infinity to 2 union 2 to infinity. Is there any local or local minimum or local maximum? No. Because again, I have just a decreasing and a decreasing. So this point here, which is where I would have had a candidate for a minimum or a maximum, is not. So no, there's none. And let's see. Let's do the concavity. So to do the concavity, I need to look at the second derivative. So I have my first derivative, which was minus 4 over x minus 2 squared. And to do that, I need to take the second derivative. Now, here's another way to do it. I would rewrite it like this, and then I can apply the chain rule quickly. So I have minus 4 times minus 2 times x minus 2. This drops down minus 3. And taking the derivative of the inside is just 1. So I'm left with minus I have a plus. So a minus and a minus, that gives me the 8 over x minus 2 cubed. Again, the critical points is where the function doesn't exist, so critical points, that's where x equals 2. So I do the same thing again. Here's 2. And just I do my my values again. So over here, I have f double prime at 0, and that's 8 over 0 minus 2 cubed, which gives me 8 over minus 8, which is minus 1, which is less than 0, which means that this is concave down, which means then it's kind of like this kind of a shape. And over here, I'll pick 3, so I got 8 over 3 minus 2 cubed over 8 over 1, and that's equal to 8, which is greater than 0, which means that that's concave up, so it's a happy face. You would have thought that this is a critical point is at x equals 2, that it would be a point of inflection, but it's not, because it is not defined at x equals 2, so no, there is none. So I have to just draw a quick sketch. I didn't have any plotting paper. Can never trust people who have graph paper, because they're always plotting something. There. So there is my grid. And I'll do 1 here, and I'll do 1 up here. I mean, come on. Yes. So using all the parts that we had from our graph, we knew from part A that I had an x-intercept at minus 2, 0. I also had the y-intercept at 0, comma, minus 1. And I also know that I had my horizontal or my vertical asymptotes at x equals 2. So there's my vertical asymptote. I also have a horizontal asymptote at 1. There we go. So y equals 1 is my horizontal asymptote. Ha for short. And so what I have is something like this. Something like this. And that matches it. So I had on the previous one that it was here, my interval was concave down on minus infinity to 2 and concave up on 2 to infinity. So in this case, it's concave down, so that works. This works. This is concave up. And I also need to make sure that it was decreasing on all the intervals. So this is decreasing, it's going down, and this one is also decreasing, it's going down. So that satisfies all the information that we had collected when we were doing this question. And that's the end of the test. We've reached the end of our time, so I've made it just in case. So there it is in about 35 minutes with me talking through it. Again, if there's any questions with the marks, like I did something, it's possible I added up all the marks. Send me an email if you're confused about what I did in terms of that. I will post the solutions here so you can have a look at them. And if you're still confused, yeah, feel free to send me an email again. But that's all that we have. Thank you all for tuning in. I have office hours from 1 to 3. So if you have more questions, feel free to drop in during our office hours and you can ask me questions. Thank you everyone for tuning in, and I will see you all on Monday.